All right. Hello again, everybody, and welcome to another edition of Tech Talk. I'm Mike Odell from the Penn, Ohio chapter of the SCTE, and today's video is brought to you in partnership with Precision Optical Technologies and the Penn, Ohio chapter of the SCTE. So with us today is Yarek Merkelov in his sixth year in the industry, all with precision optical transceivers, beginning as a production technician, learning the manufacturing and quality assurance process, and then transitioning into an engineering role for a couple of years, improving his technical skills and knowledge of fiber optic transceivers, and more recently in a customer-facing role as the regional account manager, primarily supporting Comcast. So, Yarek, thank you very much for being with us today and giving us some educational material on optical small form what?
Thanks, Mike. In addition to being with Precision Optical Technologies, I'm also on the board of the Eastern Pennsylvania chapter, which recently also absorbed the South Jersey chapter. But for today, the topics I will cover in this presentation will walk us through how fiber optic transceivers have evolved to what they are today, as well as where we see the industry heading. I'll also cover a few of the current technical limitations that the industry is actively working to overcome in order to continue developing transceivers with higher data rates, longer reaches, and smaller size. Now, lastly, I will provide a high-level overview of the different types of the most common fiber optic transceivers today and their most frequent applications. Mike, I'll turn it back over to you.
So we jokingly titled today's video "Small Form What," but SFPs I think are pretty common in today's architectures, and most folks are familiar with them. But you know the acronym alphabet soup that we live in, they're not always immediately apparent what they stand for. So small form pluggables is one of those trivia questions. Everybody knows what an SFP is. Some of us that have been around long enough to remember them as GBICs, and I think we'll talk about that too. But yeah, today is all about optics, and Yark, really appreciate not just your involvement in the SCTE and the society in our sister chapter over there in Eastern Pennsylvania, but helping us develop this content today to educate our audience more about SFPs. So let's dive into it.
Sounds good. So a little bit of the agenda, introduction to transceivers. Then we're going to kind of look at the guts, what's inside of a transceiver. Next, going to transition to the history, where it started, and how long has it been around, what does it look like. Transceiver compatibility, this one's kind of a big topic. We live in a world where, thankfully, in the US, we have a standard electrical outlet, and everything that every 3-prong or 2-prong plug works. Well, in the transceiver world, that doesn't really work, and I'll explain a little bit about why that is and what goes into the compatibility. Next is the technical considerations. So taking a step beyond the compatibility, when I talk about technical considerations, I'm talking what are we concerned about electrically? What are we concerned about optically? Next, looking at some transceiver specifications. And this one's going to be primarily tied into the technical considerations. So we're going to be looking a little bit closer at data sheets and why maybe certain parameters are looked at very closely on a data sheet when it comes to transceivers. Do you want me to continue here, Mike?
Yeah, let's jump right into it, man.
All right. This one, do you want me to cover this piece? This is more of just like a, intro that I use in some presentations.
Yeah, I think we can touch briefly. I mean, look, the reality is everybody is trying to figure out how to expand their networks, to have more data throughput, and to manage the rising need of accessibility to data, which is effectively the internet. And in a lot of instances, whether it's in fiber-based services or in HFC-based services, or potentially even in wireless. A lot of the wireless services are connected over fiber backbones too, right? So the infrastructure that exists, particularly in the optical space, is continuously being looked at to say, how can we get more out of that pipe, right? When we think
Yeah.
about the evolution of optics, where we were, fixed wavelength, single wavelength per fiber analog optics that were limited in their data rates by the optoelectronics on either end, either at the node or in the head end or at the transmitter end. I think that's been one of the probably hidden evolutions of the network, is how to get more data through the same fiber assets that we have. And obviously the SFPs, transmitter receivers, are a big part of that. And, the primary reason for all of the development in this space is the need to get more data through the currently existing pipe. So I think it's entirely within the scope of, this discussion as to how did we get here? Well, this is how we got here.
Yeah. So I think, the numbers kind of speak for themselves. One thing that does kind of blow me away is the growth. So when I first put this presentation together about 3 years ago, these numbers were 100 million households versus 125 million today. We were using 400 gigs of data versus 3 years ago versus 600 today. I mean, you've seen a 50% growth just in 3 years. And, more to your point, a lot of that is being driven by what we're capable of pushing down the pipe now. So, yeah.
And there
You
is a
might want,
trivia question here. Laser is an
yeah,
acronym. Can I guess? I didn't
yeah,
see the presentation, but if I remember correctly, it stands for light amplification through the stimulation of emitted radiation. Am I
yeah.
close?
You hit the nail on the head. Yeah.
Fire the laser.
Oh, geez. Yeah. If only. I'm really glad my wife didn't hear you just say that just now, because I say that probably a little too much at home, if I'm being candid.
That's funny. Do you have
Yeah.
sharks with lasers on their heads?
That's all I have, cryogenically frozen. You'd think in 30 years, but yeah. So there it is. Light
Oh,
amplification by stimulated
I was
emission of
pretty close.
radiation. Well, I think yours was just grammatical. You said the same thing. It was just like you said the same thing. I think we're splitting hairs. So yeah.
Yeah, so we do have a
Um,
lot of acronyms and a lot of initialisms. Ron Rannick is very precise about what is an acronym versus what it is an initialism. And I think an SFP is an initialism, but small form pluggables. So here we go.
okay. So I know there's a lot of writing on this, but bear with me. So transceiver basics at a high level, why do they even exist today? So in the early days of fiber optic networking, um, you, you would have basically what was the equivalent of an entire line card with embedded transceivers in them. Now the issue is transceivers, optics alone have a perceivably higher failure rate than electronic equipment. And the issue there was, if you had a 48 port switch with just all embedded optics, if you had one port go down, the entire switch or line card would have to be replaced. So you're looking at like a pretty expensive support contract for something like that, right? So port failures, if a port went down, in order to get it back up, again, you'd have to replace the whole switch or router. Limited data rate and link budget flexibility. So you're basically optically locked. A lot of switches and routers are written with software code where it's to help support what you have in your infrastructure today and also future proof it. So you saw a lot of switches and routers with 1 gig and 10 gig coded in their SFP ports. That was to help allow for, okay, you can go ahead and buy your 1 gig SFP today. And when you're ready to make the switch to 10 gig, you're not having to buy a completely new infrastructure. And so by taking the transceiver away from the switcher router, created some more flexibility and enabled operators essentially to help position themselves to future-proof their network. Additionally, you might be wondering why the shape of a transceiver. So several years ago, when optical transceivers became disaggregated from the switcher router, there were no industry standards. Seemingly every company would have its own proprietary form factor. I don't want to call out specific companies, but there are companies in the industry that are notorious for creating, proprietary equipment. This was also true for transceivers as well. So reality, what ended up happening is the primary industry players in this space came together to develop what we refer to as the multi-source agreement, short, acronym MSA, in order to come to a convention and help develop a product with specific technical and mechanical characteristics that would fit everyone. And the good analogy I like to use here is electrical outlets and plugs. Could you imagine if we lived in a world like in the U.S., New York used a 3-pronged outlet everywhere, and Pennsylvania used a 2-prong, or we saw some European outlets out here. Like, it'd be kind of a big old
Chaos.
jumbled mess. Yeah. So
Yeah. And so there are industries or organizations that really help with standardization, right? Whether it be ANSI or SCTE or IEEE, because there's hundreds and hundreds of examples of this, whether it be the F connector or an HDMI connector or whatever. The standardization is good for the business, to allow a lot of people to operate in that space, but also the ecosystem as a whole, to be able to coexist. So it's good to know.
yeah, absolutely. And so through this is why we see SFP, SFP plus, QSFP plus, QSFP 28 today. And there are standards documentations for every single one of these form factors. Actually, probably multiple. There's some that are just strictly the physical characteristics, some that define the EEPROM, and then some that outline the optical characteristics and performance as well. So there's a lot of effort and thought that is put into the design of these, but we are, in a way, pretty far removed from that.
For standards, training, certification, events, even membership, everything you need to know, scte.org.